Welcome to this video on making notes while you are studying. We've already seen, and there is plenty of information on the web about the importance of you making your handwritten notes, and making handwritten notes in your own handwriting. That helps you understand the material better if you do it conscientiously and diligently. It helps you deepen your understanding of a particular subject because it has to actively engage you, and with the writing being in your own handwriting, that means you have had to translate it through your own mental processes as well as engaging your physical activity, which helps you maintain attention while you're doing it. While we can say that it is important to make notes, one of the things that's not often addressed in any of the videos or some of the writing there is, how do you actually go about making notes? What are some of the thinking processes that you go through or could go through that will help ensure that your notes are effective? And that's what this video is about. So we're going to take an example of some cryptography notes and use those to examine the types of questions you might ask yourself, the types of thinking you might go through to actually help understand the subject or studying more deeply and more clearly, and to be able to apply that learning more easily. One of the first things we'll actually do is make sure that you get an overview of the subject. So you can see here as we go through this particular video that the person is just starting on the first page, and the handwriting is fine for the person who wrote it. So regardless of whether it's extremely neat handwriting or handwriting that may take a little bit of time for you to decipher, it doesn't matter. Even the neatest handwriting in somebody else's writing is not going to be as effective for you as making the notes in your own handwriting. So if you've got some notes, and here we have the first half of the Lecture 1 notes for our cryptography subject. Scan through the notes just to simply get an overview. And you can see the person here is looking through and highlighting keywords like integers, divisor, prime, so that you're beginning to get an idea of what these notes contain. While you're doing this, your brain will be going, oh, I know something about that, or maybe asking questions, I wonder what that is, I haven't seen that before. You can also see the patterns, that there are definitions, theorems, more abstract style of writing the theorems out, as well as examples on the pages. So once you've gone through and just had a quick overview to get an idea of, that's what it's about. We've got some mathematical notes here. We can see there are theorems. We can see there are abstract ways of writing those theorems, but there are examples. You already have an idea that there are definitions you have to understand, and that there are examples that you're going to want to be able to relate back to the definitions and to the more abstract form of writing the theorems. Next, you want to note key terms and points of attention. So you might print the notes out. You could do it on screen, but I would recommend that you print the notes out. And here you can see the person is highlighting the word integers, so you're starting to pay attention at a bit more detail here. Notice you're still not writing your notes yet. You're still trying to tune your brain in, and at this point asking questions like, what do I actually know about this? And why would you do that? You know that, or we know that you learn more effectively if you can relate to something that you already know. So you've probably heard about prime numbers at school, if not any time since, and you'll have some sense of what they are even if you don't remember the definition. Just to recognize that you've heard of them before is a really useful thing in terms of you setting your brain up to absorb this new information. If there's something you haven't heard of before, then you would simply be asking questions, I wonder what that is, and to simply have acknowledged that question and to know that you have that question is going to prime your brain to seek out the answer and to be more receptive to the information when it discovers the answer. So you can see the person continues to go through here, highlight formulas in the more abstract form, key terms like greatest common divisor, Euclidean algorithm, examples highlighting that they're examples to review until they get to the end, and then a quick scan through, and now the person is ready to make their own handwritten notes. So here we can see that the student has started handwriting notes on the right hand side of the screen, and the first thing they've noted down is what integers are and given an example. Now most people will have learnt about these at school, but here the student has gone on to actually go, oh, let's see where integers fit in the scheme of numbers. So they've put some extra notes for themselves to remind them that there are such things as real numbers, rational numbers, irrational numbers, and so on, so they can see where the set of integers fits in the general scheme. Continuing on, student looks for the definition of divisor. Note that the person has used red for the heading so that they're clear in this case, that they're writing down a definition. You can use a colour of choice, but the use of colour is recommended if colour works for you, and that basically means as long as you're making good distinctions in the colour range, even if there is some form of colour blindness. Having a definition is one thing, but it's important that you can relate the definition to real examples. So here the student's taken an example based on the notes and used a different colour again to highlight that it's an example, and made sure that they can relate the numbers 72 and 6 and 12 to the letters used in the definition. Continuing on, the student now notes down their definition of a prime number, and once again gives enough examples so that they can recognise the types of numbers and see the sequence that they form. Now there's a theorem involving prime numbers, and it's written in rather abstract form, as you can see there. So the next job is to relate the letter P, P1, P2, P3 through to PK, and the indices alpha 1, alpha 2, alpha 3 to a real-life example. So hence this is particularly where it's important to use an example, and notice that the student in this case has drawn a little line indicating that the index 2, so you've got 2 to the power of 2, that the index 2 is the alpha 1. The index to the integer 3 is 2, and that is alpha 2, and so on. So they're very clear about how the numbers and the divisors, the prime divisors of that number, relate to the way the theorem is written. This pattern of working continues with the next definition on prime numbers. And again, you can see the use of an example and taking particular care to make sure that the example is written out in a way that the student is then able to make sense of the more abstract way that the theorem is written out. And here, on the right-hand side of the screen, you can see that the student has continued again the same pattern with the writing out the greatest common divisor definition, a theorem involving it, and an example to make sure that they understand what the theorem is telling them. And the writing out of the example then helps you make sure that you can actually apply this particular form of knowledge. An important part of all of this is as far as we're going with this example, is that the principles are the same. Whether you're working with summarising some Shakespeare, something for critical thinking or communication course, into networking, the idea is that you first give yourself an overview. Make sure that you ask yourself important questions as you go through, such as, do I understand that? Do I remember that? If something is brand new to you, how do I make sense of that? Do I understand every term in the definition? Do I have an example that helps me understand how to apply a theorem or some piece of content in some other subject that's not mathematical, for example? You'll appreciate from this that making notes is not a passive or a semi-attentive exercise. It's an exercise that should fully engage you, should be thinking, questioning, making sense of things as you go. The fact that you're writing will help you keep your mind on the job. You should, of course, take breaks as suggested, so working for 20 to 30 minutes, then take a 5 to 10 minute break, and then come back and continue, and do that for 3 or 4 times, and then do a quick review, and then have a rest of a longer period before doing some more work. Anytime you look at your notes, you should realize that they should be easy to read, they should help you recall information, they should help you make new associations. They definitely should help you deepen your understanding of a subject as you make them and as you review them. They definitely should help you learn and remind you how to apply the content you're learning. And they should encourage you to do review sessions. It should be easy to go back to your notes if you've done them well, and it should make your studying easier than it might have been in the past. And I remind you again that the principles, the way of working, even if the content is different, the way we've been working with making these notes is the same for many subjects. So good luck with good discipline with your note making.